Hello and welcome to the Arboretum channel. Today we will be talking about different CAD programs and we need to use some simple shape because I want to make it a bit practical. So there is say the dice has been cast and we'll use dice as the interesting object that we'll be modeling. And if you look closely at these dice, you may figure out that actually you can see bits and pieces of a cube shape here, but also of a sphere over here. And if you look very closely, a dice is basically an intersection of a sphere and a cube. And we will use 3 different programs to model a dice without the dots, just the basic shape. And I will show you how these programs are different, what is easier in one, what's easier in the other. We'll start with OpenSCAD. This is a program that I learned as a first CAD software. It is a bit strange because you write a code to describe the object you are modeling, the shapes. And of course it has advantages and disadvantages, as you can imagine. So I've measured that the dice is roughly 16 millimeters wide. So we start with a cube. It will be 16 millimeters. And here it is. Now we need a sphere, and I don't know what should be the size of the sphere. So let's assume that it will be diameter will be 20 millimeters, and let's see what happens. Well, as you can see, these two are not aligned because the sphere is centered by definition, by default, and the cube starts in one of the corners is in 0, 0, 0. So what we will add here, we'll say center equals true. And yeah, it looks better now. However, the sphere is probably too small. So as you can see, everything is parametric, which is the biggest advantage of this software. So for example, we want our sphere to have more triangles and be smoother. And there's a $FN parameter for that. And we say, make it 90. And it's smoother now. And probably it needs to be a bit bigger, like 22-ish. Okay. So now we have sphere intersecting with our cube. Well, we have a union basically of two shapes. So what we want to do, we want to make it an intersection. So we just write a code, intersection of this thing and that thing. Close the bracket, F5, and intersection has an N at the end. Yeah, this is a spelling mistake. And does it look like a dice? It does. So here you have your dice, nice and easy. And if you have seen that changing parameters was pretty easy, things were aligned, also pretty easy. And there are cases where having that much control, mathematical control, programmatical control of your design is useful. I can show you, maybe you've seen on my printables account, I've been doing a Christmas tree using wine corks, and you see it's a cone where you can glue up corks, right? So what I had to do, I had to create a set of corks that will constitute a basic shape of a Christmas tree, right? And if I would be doing it manually with positioning every cylinder and manually rotating it, it would be a mess. So what I did, I created a function which is called module, creating the layer, and then just created a difference between the cut cone and the union of these layers, because this thing here is actually a cone, right? And there's a difference, and that's it. So that's the beauty of using the parametric software. Okay, so now we will switch. We know the parameters, but we'll assume that we don't know the diameter of the sphere. So let's switch to TinkerCAD, which is super simple software that runs in a browser. So you don't need to do anything. You just need to log in to tinkercad.com, use your account, and you're good to go. So I need to log in with my personal account, with Google, yada yada yada. One moment, please. Yep, and you can see I've been doing it before, but let's start from scratch. New 3D design. And I probably need to accept cookies. So we know the drill, roughly. We need to start with a cube, which is called a box here, right? We can here programmatically say 16, 16, and 16. We can also drag these boxes here to reshape. Now we need a sphere that we were supposed not to know what the size should be. Let's zoom it a bit. So now we need to align. We can try moving it by hand, but it won't be easy to do what we want to do. So in TinkerCAD, you can select two elements and use the align. And you say, I want to align in this middle, in this axis, and that one I did it manually, and then third one. And you see, it seems nice, but we know from learnings before that the sphere is a bit too small. So what we can do, we can change the size of it, but you see what's happening? We are creating an egg. So if we press the shift button, it will actually resize in all 3 dimensions, and we know it should be 22, but as you can see, it's not aligned again. So we select both. We press L for align, and we need to align in the Z-axis. And yeah, it's aligned now. And now intersection. And there's no intersection. So what we need to do, we need to actually turn one of these objects into a hole. So we will select, it doesn't matter which one we will use. We'll start with we'll create a hole out of the sphere, make a copy, Ctrl-C, Ctrl-V of the cube, and now we'll use these two. Well, I need to move it farther away. We will now group these two shapes, which will actually create this fancy shape. And we will use this shape to cut corners out of this new cube. So now we can turn this new shape into a hole. Press the L to align. Align these two and now group them, pressing the G, Ctrl G, and ta-da! We have it. So it was a bit a workaround, right? Because we didn't have the intersection, but we actually created what we wanted. Of course, in TinkerCAD, you have this object here that is basically a dice, which is a dirty hack. So we won't do that. But you've seen that you can do it even in very simple program that is purely online. And now, so we have our second cube. And now we'll switch to a very serious software, the FreeCAD. So let me launch the FreeCAD. And here we have FreeCAD 0.20.2. We'll create a new file, and you can see that this is a complex software, as usually a fully blown CAD software is. We will go to the part workbench, and we'll do the same thing again. So we'll start with a cube, and here you can see that you need to manually change all 3 dimensions, and we have cube of 16 millimeters now. Now we will add a sphere, which is here. It's way more round than the one in OpenSCAD, right? Because it looks like a totally smooth thing. And first of all, we can first align these, but then the cube will disappear inside. The sphere will disappear inside the cube. But basically, let's increase the size of the cube, of the sphere, and let's make it 11, which should be right. And now the complex part is that if you want to align it, there's no easy way to center, but we know that the cube is 16 millimeters. So if we move the sphere by half of that, so by 8 in all dimensions, then it will be in the right place, right? So now we do exactly the same thing, which is intersection, and here is the button to do it, intersection, and ta-da! And I've just installed it, that's why I cannot turn. Yeah, it can be turned now. But the power of this tool is that, for example, you can have a crazy idea that you want to fillet one of the edges. Let's say you want to fillet this edge here, right? And you say, okay, let's make it smoother. And you can't use a millimeter because it will be more than the space between this edge and that. But let's try to make it 0.4. And you see, it fits. And now you have even smoother shape. And this thing here is impossible to, well, almost impossible to do in either OpenSCAD or TinkerCAD. And here it's just done. And you can do super complex things in FreeCAD, but it is a complex tool. So you've seen it. I've done the dice in 3 different pieces of software. You have seen some change, some differences. So TinkerCAD is simple, easy to use, totally free as all others. But once you want to do something complex, it gets tough. It still can be done, but it is a lot of work. OpenSCAD is probably a good fit for people that are programmers and are happy to write a code. And it is very parametric, so you can do things that are fully parametric, and you can change some numbers, and everything is calculated based on that. So that's super useful. But if you want to do complex stuff, when you say, okay, now I want a metric M5 thread over here, or I to make a fillet on this edge, or I want to do something fancy, then FreeCAD is your tool of choice. Of course, there are other options. There are plenty of CAD programs like Blender, like Fusion 360, which probably many people will comment that is the way to go and the best one. There is Sketcher and plenty of others. So this is a very subjective selection that of tools that I used at some moment. I basically use FreeCAD from time to time. If I have something very mathematical, very parametric, then I go to OpenSCAD. And I use TinkerCAD basically only to do some demos. And for example, when I do lessons for kids at school, then TinkerCAD is a great tool because it's so simple. Okay, so that's it for today. Maybe we'll make a poll so you can tell me what tool you're using. I hope this was useful, helpful. Thanks for watching, and let me know in comments what next would you like to hear about. Thanks, and happy printing and designing. Take care. Cheers.